Hi friends, once again welcome back to our lecture series on conditional probability. In this video we are going to discuss about multiplication theorem. In our last lecture we have seen conditional probability. Those who didn't watch my previous sessions, try to watch it first. Then only you will be able to understand multiplication theorem well. Now let us move directly to multiplication theorem. So what is in our last lecture we have seen that what is P of A given B? P of A given B is probability of happening the event A if the event B has already happened. So clear? If the event B has already happened, then what is the probability of happening the event A? So P of A given B is, as you know, it is P of A intersection B divided by P of B. Let it be equation number 1. And also in our last lecture we have seen P of B given A. What is P of B given A? P of B given A is P of A intersection B divided by P of A. Let it be equation number 2. We have seen these two formulae in our last lecture on conditional probability. So P of A given B is equal to P of A intersection B divided by P of B, and P of B given A is P of A intersection B divided by P of A. So what is the meaning of P of A given B? It is probability of happening the event A if the event B has already happened. Is it clear? And what is P of B given A? It is the probability of happening the event B if the event A has already happened. So in these two cases we are given a condition that one event has already happened. So if one event has already happened, then what is the probability of happening the other event? Now from the first equation, what is P of A intersection B? From first equation, from 1 we have P of A intersection B. What is P of A intersection B from first equation? So P of A intersection B is equal to P of B into P of A given B. Is it clear? See, the first equation is P of A given B is equal to P of A intersection B divided by P of B. From this, what is P of A intersection B? It will be P of B into this. Isn't it? So P of A intersection B is P of B into P of B into P of A given B. P of B into P of A given B. See, from the second equation, what is P of A intersection B? See, this is the second equation. From this equation, what is P of A intersection B? P of A intersection B will be P of A into P of B given A. Isn't it? P of A intersection B is equal to P of A into this thing. So P of A intersection B is P of A into P of B given A. So these are the two expressions for finding out P of A intersection B. So what is meant by P of A intersection B? It is the probability of happening both the events A and B. Is it clear? What is P of A intersection B? It is the probability of happening both the events A and B. So what is the result? P of A intersection B is equal to P of B. It is probability of happening the event B into probability of happening the event A if the event B has already happened. Similarly, what is P of A intersection B here? It is probability of happening the event A into probability of happening the event B if the event A has already happened first. Isn't it? So this is called multiplication rule of probability. Multiplication rule. Multiplication rule of probability. So what is the multiplication rule or multiplication theorem? The multiplication rule or multiplication theorem says that P of A intersection B is equal to P of B into P of A given B, or it is P of A into P of B given A. So now this theorem can be extended to any number of events. Suppose we are given 3 events A, B and C. So how will you find out P of A intersection B intersection C? How will you find out P of A intersection B intersection C? P of A intersection B intersection C is probability of happening all the events A, B and C. What is P of A intersection B? It is the probability of happening both the events A and B. P of A intersection B intersection C means probability of happening all the events A, B and C. So how will you write this result? It is first P of A. First it is probability of happening the event A into probability of happening the event B if the event A has already happened. Now the two events A and B has happened. So P of A intersection B intersection C is first it is probability of happening the event A, probability of happening the first event, that is probability of happening the event A, into this is probability of happening the second event if the first event A has already happened. It is P of B given A. So P of A into P of B given A into the last third event is P of C. P of C given, what should be the condition? P of C given A intersection B. P of C given A intersection B. What is the meaning of P of C given A intersection B? It is the probability of happening the event C if the events A and B are happened. Isn't it? So the first it is probability of happening the event A. And then it is probability of happening the event B if the event A has already happened. And then it is into probability of happening the event C if both the events A and B are happened. So it is very easy to write this rule. So first you write P of A into the second event is, see here it is P of A, P of B, P of C. So P of A into P of B given P of B given A. What is the A? A is the event before B, or A is the event prior to B. So P of B given A into P of C given, what are the events before C? A and B. P of C given A intersection B. So P of A intersection B intersection C is equal to P of A into P of B given A into P of C given A intersection B. Now, what will be P of A intersection B intersection C intersection D? See, now let us extend this rule as it is. So first of all it is P of A. P of A. That is probability of happening the first event A into the second event is B. Probability of happening the event B if the event A has already happened. So what is the event before the event B? It is A. The first event is A. So P of B given A into next event is P of C. Into P of C given, what is the condition? The first two events A and B are happened. So what are the events before the event C? Which are A and B. So P of C given, both the events A and B are happened. So P of C given A intersection B into the last event, that is fourth event is D, into P of D given, all the events before D should be happened. So P of D given A intersection B intersection C. P of D given A intersection B intersection C. So this is the extension of multiplication rule in the case of four events A, B, C and D. So what is the meaning of P of A intersection B intersection C intersection D? See, usually P of A intersection B intersection C intersection C D is written as P of A B C D. So what is the meaning of P of A B C D? It is probability of P of A intersection B intersection C intersection D. It is probability of happening all the events A, B, C and D. So what is the rule? P of A intersection B intersection C intersection D is P of A, probability of happening the event A, into P of B given A, probability of happening the second event B if the event A has already happened, into probability of happening the third event C if the events A and B are already happened, into probability of happening the fourth event D and C are happened. So this rule is called the multiplication rule or multiplication theorem. So what is the multiplication theorem? In the case of two events, P of A intersection B is P of B into P of A given B, or it is P of A intersection B is equal to P of A into P of B given A. So what is the meaning of P of A intersection B? It is probability of happening both the events A and B. What is the meaning of P of A intersection B intersection C intersection D? It is the probability of happening all the events A, B, C and D. How will you write the result? First it is P of A into P of B given A into P of C given A intersection B into P of D given A intersection B intersection C. So this is the multiplication rule of probability or multiplication theorem of probability. Now let us go through a very simple problem. See, let us assume that 3 cards are drawn. 3 cards are drawn without replacement from a pack of cards. Find the probability that the first is king, second is queen, and third is, let it be, jack. Now let us consider this problem. See, you are given a problem. 3 cards are drawn without replacement from a pack of cards. Find the probability that the first is king, the second card should be queen, so it should be queen, and the third should be jack. Now here 3 events are there. So in any problem of probability, first of all, you must identify the events in the problem. So let us name the events as A, B and C. What is the event? A is the first event. A is the event of drawing a king. A is the event of drawing a king card. And what is B? B is the event of drawing, the second card should be queen. And B is the event of drawing a queen card. And what is C? C is the event of drawing the third card, which is jack. See, these 3 events should happen. So the first should be king, and the second is queen, and the third should be jack. That means these 3 events should happen. That means you will have to calculate P of A intersection B intersection C. And we know that in order to calculate P of A intersection B intersection C, we can make use of what? Multiplication rule of probability. What is that? It is P of A into, second event is P of B. P of B given, what is the event prior to B? It is A. P of B given A into P of C given, what are the events before C? A and B. That is A intersection B. P of C given A intersection B. Now let us calculate each of the probability. What is P of A? P of A is the probability of drawing a king from a pack of cards. And we know that in a pack of cards, how many kings are there? 4 kings are there. So probability of drawing a king is 4 divided by 52. So see, like a pack of 52 cards, how many are kings? 4 are kings. So probability of P of A is probability of drawing a king. I think you are well aware about the playing cards and its suits, etc. So P of A is the probability of drawing a king. So what is the probability of drawing a king? Number of kings divided by total number of cards, 4 by 52, into what is P of B given A? P of B simply probability of happening probability of getting Q card. If the event A has already happened, that means if the first event has already happened, what is the probability of drawing? What is the probability of happening the second event? If the first drawn card is king, what is the probability of selecting a Q card? See, the cards are not replaced. Therefore, one card is already drawn from a pack of 52 cards. So remaining we have only 51 cards. And in these 51 cards, how many are queued? 4 are queued. Because in the first draw we have taken a king card. Into one is P of C given A intersection B. It is the P of C means probability of drawing a jack. If the events A and B are happened, that means the first drawn card is king and the second drawn card is queen, then what is the probability of drawing a jack cards? And we know that 4 jack cards are there, divided by what is the total number of cards? Total number of cards is only 50. That means 2 cards are already drawn. Right. So 4 by 52 into 4 by 51 into 4 by 50. You will get the answer as 8. You simply just try to simplify it by yourself. 16575. So this is the answer. You check whether it is right or not. So this is the multiplication theorem of probability. Okay, I think multiplication theorem of probability is clear to you. In our next video, we will discuss about independent events. Okay, till then